Alright, so today we're going to continue looking at Pascal's triangle, doing Pascal's method. If you want to take a moment, you can just watch the animation of the triangle. So we're calling that if we add the two numbers above, we get the number below. This will be very handy for today's lesson. Alright, so here we have the street map of Mathematicalville. All these people are various members of mathematical history. Okay, so today we're going to go from the red dot down to the corner of Euler and Willis. We're over here. Okay. How do we do this? So we can use Pascal's triangle. So like we said with Pascal's triangle, the outside rows are 1, always 1. Okay, so we number those. And then we take the two terms above and add them together. So in this case, there's one path to get to this point, one path to get to this point. So 1 plus 1 is 2. So there's 2 points to get, 2 ways to get to this corner. Then there's one way to get here, okay, and 2 ways to get here. So 2 plus 1 is 3. Always remembering that we can only go to the right and down. So we keep filling in the numbers. Let's see. Let's continue the pattern. Right, so now that we're on Will's lane, the pattern changes a little bit. We're still going to use our previous two values. So there's 20 paths to this corner, 15 paths to this corner. So to get to this corner, add them together, so there's 35 paths. And the other 3 continue with our pattern. So now that we're run out of space to go to the right, then we have to come down. So 21 plus 27, or 7 plus 21 is 28. 35, 21, 56. 35 plus 35 is 70. We add 70 and 56 to get 126. 56 and 28 is 84. And 126 plus 84 should give us 210. So there's 210 different pathways from our starting point with the red dot going right and down to this corner over here, Will's Lane and Euler Boulevard. This is an example of how we can use Pascal's method to find out the number of paths from one point to another. We can also do this using word patterns, same idea. So we're going to start with P and end with L, and see how many different ways there are to spell Pascal in this array. So again, from P to A, there's only one path. Passing down to the S, there's one way to get to this S, 2 ways to get into this S, one way of getting to that S. C's, again, we can see it's the next row in Pascal's triangle, 1, 3, 3, 1. The next row, we have to cut off the 1s since we're not continuing on in those directions. So we just add the 1 and 3 to get 4, and 3 and 3 to get 6, and the 3 to 1 to get 4. We add the 4 and the 6 to get the 10. And since there's 2 10s, we add those together. And that gives us a total of 20 different ways to spell Pascal. Right. Another pattern that we might see is on a checkerboard. So how many different ways can we move this checker following the rules of checkers of going up into the angles on the diagonals? Again, get from this point to this point, there's only one path. Over here and here. To get to this square, we can either go this way or that way, which is two paths. And then here is 3. Similarly, there's 3. So to actually move on to the x, add those together. So let's move on to the x. We add 2 3s and we get 6. So there's 6 different pathways to get move from the checker from its starting position to the x. Okay, so those are some ways that we can use Pascal's method. Again, in class we'll be exploring and looking at other ways that we can use this to try questions 1, 2, and 3. And we'll see you tomorrow.